Hey everyone. So I'm Sundelin. I work on product at NetApp, AI products specifically. Arindam's our technical fellow. We're going to spend the next 43 minutes and 43 seconds talking to you guys about this AI data engine. Love for it to be a discussion, so please, interrupt, ask questions, etc. Prefer if you didn't throw things, but questions are very welcome. All right, here we go. I'm going to do a quick level set. Just spend a few minutes. Why are we building this? What are the problems we're trying to address? What do we hear from customers, etc. Talk about some product outcomes, and then Arindam's going to take over, and he's going to talk about the architecture and design and some of the design principles. And again, love for this to be a discussion. So first up, this is news to no one in this room. The promise of AI for enterprises is enormous. You've all heard eye-popping numbers. I'm going to share just a couple more. 78% of businesses now report that they use AI for at least one business function. 92% of executives say that they're going to continue to increase their AI spending over the next 3 years. 35% is the projected year-over-year annualized growth rate of AI spend by enterprises. 3.5 trillion. This is one of the much more conservative numbers that I was able to find, which is why I felt a little more comfortable putting on a slide. This is from a study from McKinsey, and this is the projected incremental global economic impact of AI for enterprises, for generative AI specifically. So that's the promise, but it's a tale of two cities. Because the reality is, for a lot of enterprises, this is not the case yet. Maybe you guys saw MIT published a study that's been widely circulated. Talked to a lot of CIOs, CTOs. 95% reported that their AI projects have failed to deliver any sort of measurable impact to profit or loss for their business. 95%. 85% of projects, of all the companies we talk to, fail to ever even make it to production. AI projects, 2 times the failure rate of non-AI projects. And 30% never get past proof of concept. And a lot of these aren't small proofs of concept. These are dozens of full-time employees, sometimes more, months, sometimes longer, just to get to a proof of concept that isn't viable. So this is the reality for so many enterprises today. Why is that? We've talked to a lot. We've heard from over 1,200 SMEs from different enterprises on their experience with AI. Sat down, had very detailed conversation with over 100 data flows, tools, platforms, use cases, and talked to dozens of analysts, read countless reports, I'm sure like yourselves. And really, consistently, what bubbles to the top, the biggest blockers for widespread adoption by enterprises of AI are these 5 items, and they're all related to data and data infrastructure.
The context of this is, I think, at stage 2 or maybe even 3 in AI implementation. Stage 1 is experimentation or sandbox, if you like. Step 2 is maybe a sort of a maturation, like where is this going to go, how's it going to fit? Because failure in those stages is very common right now. If you want to categorize failure as we're not going to pursue this line anymore, right? I'm treating a lot of the data we hear, or a lot of the data points we hear right now about 80% failure and that sort of thing skeptically, because I can't tell if it comprehends this fact that this is a really new area with tons of experimentation, a lot of investment where the outcome is not some kind of business outcome, but learning and iterating. So can you comment on the use of the word fail on this slide?
Not their studies though, so I would assume just not to complete, right? It's Gartner studies, it's Oza studies, it's MIT studies.
I don't care who the source is though, man, because I want to see those questionnaires, see what was actually asked. It's just like public polling, where how many of your AI projects do not go into production might be.
I don't disagree with you. It's just It's not NetApp studies.
Yeah. So also NetApp studies show an 85% failure rate from all the customers we've talked to. So very close.
So now you're on the hook to explain what a failure is now. I
know that was really kind of you. Here I am. It's a great question. There's unquestionably a dichotomy. These are all self-reported numbers, of course. For all the companies we've talked to, you're right. There are those that are kind of much more sandbox contained, proofs of concept. However, in all cases, these originated from and were kind of widely known and visible to kind of leadership in the company because particular business problem They thought AI would be a good fit.
Yeah, that's another kind of failure again, because the failure begins with the please go add AI to this mandate.
Yeah.
So, okay.
Yeah, so there's absolutely a spectrum, no question about it. That is kind of the spectrum or spread we see of things that are characterized as failures. The other thing you brought up, which is an interesting point, is you kind of called it phase 1, phase 2, phase 3. Some of these actually are big impediments even to the experimentation stage. So let me go through these 5.
That's a good perspective, Ted.
Yeah, let me go through these 5 and then let's circle back and talk about that specifically. Is that okay? So I'll go through them quickly. Again, please keep the questions, comments coming. First off, operationalization. This is far less relevant to experimentation stage. Production AI systems. Companies we've talked to, again, we have the external data from studies, internal from these over 1,000 enterprises we've heard from. What the companies we've heard from, 13 or more is the average number of different tools and platforms they have to deploy, integrate, maintain to get an end-to-end AI pipeline, right? All the way from data discovery, search, cleansing, prep, feature extraction, training, tuning, all the way to inferencing, 13 or more. So the operationalization of a true production AI pipeline is very complicated. This is a big stumbling block. Second is, and this is where experimentation also gets hit, is data silos. When you look at specific failure vectors, number 1, for all the companies we talk to, is just being able to find and access the right data. And that's true of experimentation as well as actual production systems. There's a good reason for that. And that is simply, as companies, we have big, complex global data estates, right? Different clusters, different data centers, different topology, on-prem, hybrid, cloud hybrid. And for good reason, those historically represent silos, different data owners, data stewards. The problem then is if you have a practitioner with a specific business problem, they want to go determine the viability, do some experimentation, finding the data that is available and owned by the company that can be brought to bear is a huge challenge. Data management's a huge challenge. This can afflict experimentation to a limited degree as well. Again, companies we talked to, GK from the main stage, he said 6+ copies. That's external data from IDC. Companies we talked to, 7+ copies, very close. Problem is the same, lots of copies of the same data sets. As you take it through all those stages we just chatted about, and that means exporting, synchronization, trying to govern, and keep things up to date as the source data changes so your experimentation and production systems are still reflecting the up-to-date reality. Threats, all our data is always under threat. Generative AI opens up new attack vectors, some of them pretty sophisticated. The vast majority of existing security solutions do not address them well. So companies are now left to build their own solutions for generative AI workloads or really try to customize off-the-shelf solutions. This is a big challenge. And then finally, cost optimization. And this really is at the production scale, not the experimentation stage. Trying to manage through all these dimensions of complexity, doing it really high scale at manageable cost so you actually get a positive ROI is a big challenge. These are the 5 we consistently hear. And as I said, some of these afflict experimentation, particularly data silos and some of the data management pieces, and others are kind of squarely related to production workloads. Any disagreement with this? Your guys' experience been different? Otherwise, we can keep on cruising. All right, I'm going to keep cruising. So that's the reality. This is what I like to call the new reality, the AI Data Engine. You guys have already heard a lot about it. Sounds like you have a lot of questions. Love to hear those. You have your storage, your data on one side, and you got your generative AI workload or application on the other. Those 5 big data infrastructure problems in between. The NetApp Data Engine is intended, is a unified platform that literally goes straight from your raw storage, logical extension, seamless extension of ONTAP, Arindam will talk more about this, all the way up to data serving. And not only is it a single platform, it's a single platform that addresses each of those 5 problems. Unified control plane, storage admins, IT admins, still just system manager. These now show up as compute nodes as part of your storage cluster. Finding the data, break down those silos. We will index whatever portion of your global data state you'd like. AI Data Engine will index it, create a searchable, structured, rich search semantics, metadata catalog. Again, Arindam will talk more about this. Current, source data changes, added, removed, updated. Single working copy, end-to-end pipeline, always kept up to date and in sync with the source data itself, wherever it lives in your global estate. Governance security, Arindam will talk about details. Baked in, day one, purpose-built for AI, continuously classifies, monitors gives you a lot of flexibility and power as far as policy, attribute-driven policies for all that enriched metadata about all these files that it's constantly classifying, and then gives you the ability to just define activities based on that. Don't include this data for this particular AI app or set of users, obfuscate, redact, et cetera. And then finally, transformation. Arindam will talk a lot about this, but RAG, single most common modality we hear from all of our customers for attempting to build generative AI app, makes a lot of sense. In order to do the retrieval leg of a RAG pipeline, you need semantic search. Most common way to drive that now is with vector indices, vector embeddings, going from raw data to vector embeddings, 10 to 20x data bloat at a minimum. All the companies we talk to, we've heard much worse. You guys are smart, you can do the simple math. If you've got tens of terabytes, hundreds of terabytes data set or bigger, this quickly becomes a very significant cost and resource consumption vector.
I have a basic question.
Yeah, of course.
So, does the engine only support NetApp storage sources and databases, right?
Yeah, great question. The short answer is at launch, just NetApp.
Okay.
That's our initial primary focus. We have a much broader vision.
Yeah.
If you're interested and available, we actually have a breakout session today, 4418,
Okay.
where we're going to talk about that broader vision. GK started to lay out, he talked about this global metadata fabric,
Yeah.
and he talked about all these different data sources and having attached compute and storage, and then this global semantic knowledge graph so you could traverse and find.
Yeah.
And that's where we start to pull in these other data sources in addition
So that's
to
just a launch scope,
Absolutely.
not the plan. Okay, thank you.
Absolutely.
That makes
yeah.
sense.
No, it's a great question, actually. All right. With that, you see the NVIDIA logo. We're going to talk about that more. Very strategic partner we co-developed this with. But I'm going to hand off Arindam to start to dive into the details.
Good afternoon. This is Arindam. I'm a technical fellow. I actually architected both AFX and AIDE. So you've heard about AFX, I think, in the morning. We'll talk about this part. We'll quickly get into how we took disaggregation to the next level, right? We announced AFX, this insight. And what we are doing is we are making the storage controllers decouple from the shelves so that you could add capacity independent of the performance. So if you need performance, you add controllers. If you need capacity, you add shelves. And everything is stitched together with high performance interconnect over redundant pair of switches. And this high performance interconnect is 200 gig plus Ethernet and NVMe over Rocky, NVMe over Fabrics with Rocky. So this is what we launched. Now, where we have gone taken one more step is we have added these data compute nodes in addition to the storage controllers that can now do the data processing for AIDE or any form of AI-related workflows. So, and these data compute nodes are actually armed with NVIDIA GPUs as well to do all sorts of data crunching for guardrails, vectorization, and others. Okay, and again, they're all connected to the same cluster. It's the same cluster network, so it's the same secure boundary, same trust boundary as your cluster, so you do not have to think of doing anything extraordinary to maintain your security posture. This also ensures that we have high bandwidth connectivity inside the cluster, so you get all of the performance. And thirdly, it is the same ONTAP experience that people are used to. It still uses the same ONTAP management gateway for people to manage it. So it gives the same experience. People do not have to learn another platform in addition to what they already know.
So are the DCNs running a version of ONTAP, or is it separate?
The DCNs are, in terms of the OS, it's not running exactly ONTAP per se, because the ONTAP does the storage functions, the file system functions. This does more of the data functions. So these data compute nodes actually run on Linux, and we have microservices spun up on them. But they do talk with ONTAP a lot, as I will talk through you in the upcoming slides.
So the data flow, so those actually, even though they're connected to switch A and switch B, they're still clients of the controllers. They don't talk to the disk shells themselves.
They are, So they don't come through the cluster, externally visible cluster IP.
No, they go through the cluster network.
Cluster network,
to
yes.
talk to the nodes.
Yes.
But they don't talk to the shelves themselves.
At launch, they are not talking to the shelf. Going ahead, what this allows us to do is, because I know the data layout on the shelf, I know how
Right.
this software knows how ONTAP works, so I can talk to the shelf if need be for optimizations.
Eventually.
Yes, eventually.
Yeah. To probably different hardware or better hardware to go and. Okay.
Any other question on this one? Okay. So let's go through the building blocks of this AI data engine. So as Tori said, there are two different personas who are going to access this engine, right? One is people who set up the infrastructure, set up the platform, set up the hardware, set up the volumes, right? For them, we have the ONTAP system manager. So this is typically going to be your IT admin or the storage admin, or setting up your infrastructure for your operations. However, we also have an AIDE console where you have data engineers and data scientists coming up and creating workspaces and other stuff like collections, data collections, that I will talk about in the upcoming slides. Okay? So the first thing in the sequence of steps that we have is the metadata engine. So what this metadata engine does is it decouples the file system metadata and lays it out in a very structured, queryable fashion, accessible out of band, right? So that you can query all of the data through REST APIs. You could also add things like, apart from the file system tags, you can add custom tags. Say that this is a picture of Shrek, for example. This is a picture of Shrek with a grumpy face, for example. You could add those custom annotations so that you can use those tags to search on your data set, which typically, if you go through the file system metadata interface, you are not allowed to add too many custom tags. So this allows us to add those custom tags. It also allows us to take it out of band so that the file system I/O is not impeded because of metadata operations. Okay, so we lay it out in a very well-defined, highly granular, and custom annotatable fashion. And we store it, persist it in an ONTAP volume so that we can query it. It gets all of the ONTAP resiliency in terms of preserving the data, in terms of updating data, right? We have all the two-phase commits going on so that this and the actual file system are kept in sync at real time. Okay? So this never lacks the file system. This is what the file system is, even though it's out of band. Okay? We have a data sync and change detection engine. So what that does is, so the beauty of this architecture is I can attach all of your current deployments to this AI data engine. So if you have a NetApp estate, and Tori said, future we'll go ahead and look, we have bigger plans. But for now, if you have a NetApp data estate, you can attach it to AI data engine. And the simplest thing you have to do is set up a SnapMirror schedule. Once you set up a SnapMirror schedule, data automatically starts syncing because we have a data sync and change detection engine running here. By the way, this is a SnapMirror target. So there is some part of SnapMirror code running. And then we have SnapDiff also running on this one. So even though the entire ONTAP suite is not running, we have some parts of ONTAP running here so that we could do the change detection once data is synced, right? And you could sync it. Your SnapMirror schedules could be an hour, a few minutes, days, whatever your data change rate is. And because it is SnapMirror, and I think all of you are aware what SnapMirror can do in terms of efficiency, in terms of security, in terms of incremental data updates, you get all of those benefits.
So are you're SnapMirroring from the external NetApp data estate into the AFX cluster?
Yes.
You're not SnapMirroring it into the DCNs?
No.
And the DCNs aren't showing up as a SnapMirror target, it's the AFX.
It's the AFX.
Yeah, that was
yes.
unclear, thanks.
Okay. Thank you.
So, I think this is a dumb question, but Where does the AIDE live? Does it live on an AFX system?
The AIDE lives on an extended AFX cluster, but on DCN nodes. These are separate nodes.
Okay, so where can that data be then? It's on a server or it's on the...
The data is stored on the AFX cluster, as you were saying.
Right.
But because it's all connected through the internal switches, the DCNs can view that data.
And so
Okay. Let me show you through the other diagram. So if you look at this, this is actually the SnapMirror target, which is the AFX nodes. The DCN nodes are where your data engine is running, but since they're all interconnected to the same cluster.
I get it. So on the other side, on the next side, what I'm trying to get to, so this is all living on AFX, but then you can snap in other versions of NetApp?
Yes.
Or not?
Yes, because your AFX nodes in that cluster is running ONTAP, all of ONTAP.
Yep.
So they can act as the SnapMirror target.
And the DCNs are pre-provisioned appliances, or
They are.
I think that was where I thought you were going with it. Was
Yeah, I kind of
got a little cluster of
understand that that's all
DCNs here
together.
running AIDE. I'll call it AIDE. Are they pre-provisioned appliance-like?
Currently, at launch, they are an appliance, right? It's NetApp appliance. But very soon after launch, we will try to go the OEM route because we do understand that to run the latest and greatest models, you need the new GPU architectures. And so we would like to qualify it on other hardware that has the latest GPU architectures.
Yeah, that's
Question
fabulous.
I didn't know I was supposed to ask.
So you're going to allow lots of third-party OEM stuff to connect to your internal cluster switches?
We'll have to maintain an interoperability metric so that what we support. But yes, we are going to open it up and run more and more use cases, allow other hardware, bring your own hardware on this platform.
And so the actual metadata lives on the AFX?
Yes, the metadata volume lives on the AFX, but the software that accesses that metadata is running on the DCN nodes.
Which is interesting in terms of chattiness of these protocols and metadata searches against standard file system protocols, tree walks, et cetera. All that traffic now, really much richer search semantics. All that load, we saw, I think it was like 70% of NFS traffic and typical workloads were related to metadata queries. Show me the tree, walk the tree, who owns this, when was it updated? All of that now, you get much richer query semantics, and you point all of those queries to these data compute nodes. So not only does it not burden down your storage controllers, it actually helps lift a good amount of load off your storage controllers on these dedicated devices.
Because most of our customers do a lot of LS, does a lot of find. Find dot minus name, like you know this, right? And they turn out to be file system tree walks. That kind of congests the protocol IO path. Now they're doing REST APIs to understand all of their metadata. The protocol IO path is kind of decongested.
Since you brought up congestion, you have the DCNs connected to the cluster network, and they're clients of the nodes. They're going to make requests of the nodes for data that will go to the storage path, which is the same connection from the nodes that it's servicing the DCNs. So they're so the nodes have, I'm thinking, well, two, but one to each cluster, however it's wired up. Your DCNs are making a request. Storage nodes talk to the storage on that same path. Storage nodes talk back to the nodes, which then talk back to DCNs on that, all coming over the same paths. You're not concerned with congestion there?
See, this is an internal network, so we can design to the load. It's the front-end network congestion that I was talking about.
Yeah, no, I get it.
Yeah, so in this, we have designed it enough so that we have, for the required SLAs, we have enough bandwidth.
Okay, so you have SLAs published. Got it.
Yes.
Is it a single metadata store for the entire AFX cluster? Or can I have multiples? Or
It is a single instance of metadata store. And since you are, let me play this out a little bit, since you're also connecting it to other deployments, right? This actually serves as the global metadata store for all of your NetApp deployments. So you can now browse all of your data sets from one single pane of glass.
How do you feel that's going to scale from the point of view of, well, I asked about this earlier as well. So as this metadata is going to need to be versioned, controlled, and I'm going to be able to prove lineage
Yes.
and all sorts of things. So
Yes.
as a singular store, that feels like a bit of a limitation. I would want to be able to break that out based on different data sets or different sources or other things so that I can control some of those.
You're asking questions 2 steps ahead, okay, which is awesome, by the way, and that is where our vision to the knowledge graph goes.
Right.
So we believe that this centralized metadata store at a point will not scale. That's where decentralization comes in. So going ahead, when we introduce AIDE and bring it to the brownfield, right, and have it support AFFs, at the time, all the metadata could live within the AFFs, but your single indexed engine, which is your knowledge graph, that's the thing that's going to reside on AIDE. So you are basically using that index like internet crawlers, right? You used to page rank everything and it would show you. So that's our concept of the knowledge graph. So that's why I said you are jumping 2 steps ahead. Going ahead, our knowledge graph is an indexed view of all your data estate, and the detailed metadata would reside within the individual clusters. Okay, awesome question. Any other questions on this one? Okay, I'll move on because we have 18 more minutes. All right, so the other important step here is vectorization. And vectorization is basically, you can say that, hey, this is my data estate. I have a workspace, which is my data that I want to really make use. And from that workspace, we have another step that we take is creating a data collection. So once you say, hey, this is my data of interest, I want to create a data collection, you can take your data collection and vectorize all of that. Means you're taking your data sets, you're chunking them, and you're embedding them, and storing the embeddings in ONTAP volumes. Again, stored on the FX, but the engine, the vectorization engine is running on the data compute nodes. So what it really does is it now opens your data up for semantic searches, right? Because unstructured data, as you know, there is no schema. And to establish correlation, you need to do semantic searches. And that is what our vectorization engine does, is enables it to do semantic searches. And we take it very seriously as to the fact that Tori touched upon, that there is a 10 to 20x data bloat every time you do vector embeddings. And I could go through the math with you why it is bloating that much, but we take that very seriously. For us, we reduce that bloat by about 5x because we do a series of steps to quantize the vectors, to do chunk deduplication, and then lay it out in a very friendly manner for storage compression to compress it, right? So we take 3 steps to reduce the data set by about 5x. But we also do one thing called re-ranking. When you're doing the retrieval, it is basically giving you back the accuracy, because people might ask, if you're quantizing, you might lose the accuracy. So what we do is, when we are doing the nearest neighbor searches, instead of doing k nearest neighbor searches, we do 3k to 4k nearest neighbor searches. So that we give you, and then we re-rank it so that you get your accuracy back. So that way we kind of compress the data set. Like if 100 terabyte could become 10 times 1,000 terabytes, for us it would be 200 terabytes.
What about backing up and restoring the data set?
So the 2 ways to look at this: yes, we will do backup and restore, right? Because that's part of all the regulations and compliance to look at this one. That's a fast follow. But you can always recreate your data, because it's your source data is a SnapMirror target residing on the AFX. You can recreate your vector embeddings if you want.
So, first of all the optimizations you're doing, is that regardless of the embedding model that's used?
Yes.
So no matter what mode,
what mode,
are you able to upload your own embedding models?
Today we use NVIDIA models.
Right, and well, yeah, and let's say I take and I fine-tune an NVIDIA model. Can I use my fine-tuned NVIDIA?
So yes, we would have to do that going ahead because industries like healthcare, for example, they need it. They absolutely have to fine-tune it, modify it based on their requirements and their regulations. So yes, in the future, we would have to open it up and allow customers to bring their own models, but you have to co-engineer that with them.
But the embeddings themselves are kept on the DCNs?
Kept operated by the DCNs, kept on the AFX volume.
Okay, so if it's on the AFX volume, okay, along with the same data, right?
Yes.
So if there's a snapshot, and I get an updated embedding model, I rerun my embedding, and I may want to keep my old embeddings because for lineage and all that kind of stuff.
Absolutely.
That now stays in snapshot, and I now have, especially if it's 5x instead of 20x, I have 5x, I might have a huge snapshot usage from embedding to embedding because I have my snapshot block still used. I know Fabric Pool is not yet in AFX, but it's coming.
Very soon, yes.
I'm assuming Fabric Pool is the answer to how do I get that stuff to something that I...
So that I could preserve my snapshots, a lot more snapshots, yes.
Right, I guess you have to.
Yes.
Right?
Yes. So that is why embedding it with the ONTAP technology gives us that advantage, because I could do all of the workflows, all of the regulatory compliance needs. I could serve all of that, right? And maintaining lineage, all of that is possible with ONTAP tech.
Great.
Okay.
How do you ensure that the embeddings are secured and protected to the same level, the underlying data, that they're vectorized?
Because it's in the same.
Do you understand that?
Awesome question. So there are two ways of doing this, right? One is the access and one is the embeddings themselves, right? So the access would be preserved by the same identity and access management that the source volume is, so that there is no data leak here. Only people authorized or services authorized can look at that data.
Through that, whatever data access they have.
To go through your IDP, authenticate yourself, and then come. Right? And the embeddings themselves, ONTAP has encryption technology. So if you enable the encryption, they're all encrypted. Okay. So that's another advantage we get by integrating this with ONTAP. Okay. And the third, but a very important piece, is the guardrails. This allows us to put classification to your data sets. For example, you want to mask out PII, PHI information. You could set policies and say, I want to mask out, redact PII or PHI information. You could do that. Like when you set up I said you have a workspace and then you create a data collection. So when you have a workspace, and say, go scan the workspace and mask out or remove sensitive files before it makes it to the data collection. We could set those policies. And whatever your policy is, we will do that. And make sure all of the data that is now included in the embeddings is anonymized data, because your models can come and query the data. We have to keep the embeddings anonymized.
Does it support both fully redacting, like just not serving up a credit card number, but also masking all but the last four? So both of those?
Removal and reduction.
And is this NetApp code, or are you using the NIMS stuff that NVIDIA publishes for the curation and guardrails?
No, this part is NetApp code.
It's your code, okay.
Yes.
So when a workspace is created, when you say I have access to this data, that's the data set I want to build over here in my little workspace I created. This is what I've been trying to wrap my head around. So when that happens, does the workspace have a copy of the data then for the data scientist to work on? Because you might have a set of data that two different data scientists want to work on two different ways.
So you clone the workspace.
Okay.
And that's an ONTAP clone. That's an efficient, And so then two different data scientist teams can work off.
And then you can restrict what they are able to see, like she was asking, different ways. They set their own parameters.
Each workspace may have, or collection may have their own policies that you set. And so each set of users could view different things. And I use this example. If George and I are looking at the same set of documents, same financial documents of NetApp, we should see different things. And all that is possible because the policies are different. And the privileges that George and I have are different.
Okay, so having said that, obviously it's pretty powerful to allow data scientists to be able to create their own workspaces, which are actually snapshots of data sets. So for the data scientists to be able to do that, what kind of tools are there available on the operations side so they make sure they don't run out of space to host all the snapshots for all the workspaces?
Okay, that's a very good question. So the tools will come from the AI platforms they use. Like we are integrated with Domino Data Labs, for example. If a data scientist just use this, all of their workflows come and call a snapshot inside our platform. So all that works. Now what happens is if you're running out of space, as an example, the usual space alerts go to the storage admin, right? And the storage admin can then augment storage, right? So, and you can set those thresholds as you do in ONTAP, right? To say that, hey, I'm 80% full, send that.
They can augment storage as well as they can, if need be, they can remove data collections, embeddings, workspaces. They have the ability.
Well, they're snapshots, they can't, it doesn't matter. But.
Yep.
Do they have the ability, sorry.
They can remove the snapshots. They can also look at, because your metadata is going to tell you which workspaces haven't been touched for a while. Maybe your project is over, right? So you can go ahead and remove the workspace as well.
So I was going to ask one more thing.
All right, go ahead.
Thank you. So does it have the ability is the only place they're allowed to create those workspaces on AFX, or can you
the workspace creation is happening through the system manager. You create the workspace, but then the workspace can be used by the data engineer. And then the data engineer can create a further subset that we call as a data collection, right? And the data collection is to be used by the data engineer or the data scientist. But that is visible through the AIDE console. Remember, we had two ways of access. One is the system manager for the storage IT admin. One is the data engineer, data scientist coming through the AIDE console.
Can these workspaces be created in the cloud, or can they be hybrid?
Yes, we should be. So this, as you see, right, this deployment, one of them could be in the cloud, right? And so we have a hybrid workspace from your data estate, because most of our customers, enterprise customers, have a hybrid deployment. Yes.
So if you're, I'm piggybacking over one of her 5 questions ago, was, that's a dig. If I've got 2 data scientists that want to work on and create a workspace, technically I could, and if they're starting with the raw data, they may want to choose 2 different embedding models for different purposes, perhaps, or different versions of the same embedding model. Can I have multiple? I guess I'm flex cloning it. That's an independent volume, so I could have 2 different embeddings.
Yes.
Is that how it would work? I'd have to have 2 different sets?
Customer may have text as well as images as well. So you need different embedding models for that as well, right? And right now, for every data modality, we have at launch a single model, but we would soon need to look at those options that you're saying, because some data scientists might be under a more stricter regulatory requirement and may need to drop in their model.
Or they're just snobs and want to use their own embedding model.
Yeah. So we have to look into that as we look into the future. Yeah.
That would never happen. Data scientists are all very reasonable people.
Very reasonable.
Yes.
Don't have any attitudes ever.
So, and data anonymization there, do you mean you're anonymizing the data, or is that just referring to the redaction?
It is, one of them is the redaction.
Yeah.
Right. So that's the main one we have.
Okay.
Yeah.
Okay. So not differential privacy or one of the anonymizing tools or something like that?
That's something that we're looking at in the roadmap. Okay. Yep.
Okay, thanks.
And can we, so with the anonymization of the pieces, right, for auditing and compliance and other, can I prove that the data set was the same regardless of who saw what? So are there any cryptographic hashes, Merkle trees, anything that I could use for audit purposes to say, while it looked different to them, it was the same data set, and prove it?
Yes. Our source data, where the actual data is, we are not going and modifying that.
Yeah, but there's no, rather than giving up the entire source data to an auditor to say, yes, it was the same, I'd rather just give back some kind of proof that it was the same.
Yes. So that's what I was trying to head at, is our source we don't go and redact on the source itself.
Yeah.
We update metadata for the user to say which, if it's a file, this file had sensitive information at offset X and length Y. I have redacted that.
Okay.
So whenever that user is coming and retrieving data, I am applying those rules. But the actual source file is not, is still having the actual data set.
Okay. And so if I've got lots of different versions of this, how am I able to track the lineage and the changes? What if I wanted to reproduce certain results? So this version of a metadata store, this version of the embeddings, I ran at this point in time. Is there a way of us tracking that?
Yes. So every time you are creating, so we actually feed off of the metadata engine for versioning, because that's a single view of the entire estate. And all of the vectors and the guardrails that we apply, we are versioning it and tagging it to the metadata version.
Okay.
Okay, so you should be able to go back to previous versions and replay everything that the previous version had.
Perfect.
Okay, and again, the versioning is made possible because we are using ONTAP snapshots. Okay, so they're all built into the workflow.
And so just to confirm, the NetApp data estate, that is the AFX, and then also NetApp cloud resources?
AFF, FAS,
Okay.
all of NetApp deployments, yes. And storage grid will be fast following with storage grid as well. It's not only ONTAP, that's what it is.
Okay.
Yes.
One back onto the metadata engine. If I work in a specific field, financial markets, healthcare, whatever, can I bring in existing ontologies or taxonomies that I may have already built to fast forward the metadata?
Are you talking of setting policies?
No, I mean like bringing in my own RDF or JSON-LD that I've already created. So I've already written ontologies for the data that I have. So rather than having that all redone, I want to just bring my classifications in.
And you would like to upload your classification so that...
Yeah.
Yep.
That's a good suggestion. We can look into that.
And that would work really well with two-way, right? So I've got my ontologies that I've been developing.
Yes.
And then you've got the ones that you are learning.
Yes.
And they could feed back into my ontologies.
That's actually an awesome suggestion, because we are just that's why updating the metadata is important.
Yeah. Exactly.
Right? Because you're updating your metadata and asking us to kind of align with your metadata.
Yeah, exactly. Yeah. And
Yes.
then my ontology might improve based
Yes.
on that. Yeah.
Yes.
And things like the Azure Information Protection, which we've already, spent all this money doing. I understand right now that isn't integrated, right? But
Yes.
maybe some.
That's an awesome suggestion. We'll take it back. Tori and I will take it back.
Your customer come to you, you go to them.
Yes. All right. Okay. And then we kind of talked about all of this, so I don't need to talk about anything specifically on workspace, data collections, access management. We do have a very rich ISV ecosystem integration. So we are, as I said, Domino is one. There are others. We are working with LangChain and others. There is, plus NVIDIA is our strategic partner. We wanted to be in the hands of as many AI practitioners as it can be. So we are not stopping people from using AI platforms that they want to. We would like to integrate with all of that. That's our story. All right, so NVIDIA, as the name, as I just suggested, we have a very strong collaboration with NVIDIA for the models. We are running their embedding models as well as the re-ranking models. And we would like to leverage all the innovation that they are doing for this world, because they are the leaders. And again, our DCN nodes are powered by NVIDIA GPUs. And we are working to bring some of their newer tech, like the Blackwell family, and support that as well. So you see some of the stuff we have done with NVIDIA, and we'll continue that. NVIDIA RTX Pro 6000 server that you see is basically the newer Blackwell generation of GPUs that we have already integrated with. It's not available as a product yet, but we have done the integration. You will see that as a fast follow. Yes.
One quick note on that is, as Arindam talked about, right? NVIDIA, best in the world compute for AI, huge investment in models and software to run on that compute, optimize, keep pushing the boundaries. As Arindam mentioned, as part of our shipping software stack, we have their embedded models, and it's not their off-the-shelf embedded models. We've actually co-engineered and co-developed to optimize those models to run on our appliances and as part of our software pipeline. It is deeply embedded, co-engineered, and co-developed. It's an element I'm really excited about, and the results we're seeing are pretty fantastic as a result.
All right, and so I talked about the ecosystem integration. So we have, a full, suite of AI platforms that we are integrating, and some of these are very popular names, as you can see. So, with 41 seconds left, okay, or I'm over time, maybe 44 seconds. Just a few takeaways. You can read that. I think the most important thing is we bring some of the value adds of ONTAP. Like by integrating this with the ONTAP technology, you get to use things like SnapMirror and SnapDiff as part of the workflow, right? So you have the most efficient Delta engine and the most secure Delta engine that can look at all the change sets. I talked about the data bloat reduction by 5x. So that's a huge benefit you get. And then we are the only company that have 1P with all the major hyperscalers. So if your data estate is across any of the hyperscalers, your workspace can reflect all of that. So a true hybrid workspace. And then future ready, right? We talked about knowledge graph and supporting agentic AI. We are already partnering with NVIDIA, like those of you who saw the featured session that we had with NVIDIA yesterday. Like Carrie Brisky was on stage, and we talked about some of the innovations we are bringing with agentic AI, where eventually, once you get the knowledge graph to be reflected, from there, you just talk to agents, secure agents, that go ahead and talk to your data. And your data and the embeddings are transformed always in place. All right? Any other question for Tori and I before we wrap it up?
I have many, but we don't have time.
Yeah. Seriously.
Could we have like 2 more hours?
Yeah, gotta get some real world. Is this going to be on Lab on Demand?
It is already on the Lab on Demand.
Not the guided one, like a real Lab on Demand with real stuff. Like.
So there's a hands-on lab here.
I know that.
Okay, and then yes, stay tuned. We're absolutely have a Lab on Demand version that's developed.
We
that
have
will be
already
released.
have gone through EAP programs, so NVIDIA, we have gone through EAP with them. We have other partners we are doing early access programs with.
Cool.
Yes.
With our negative 3 minutes, can I make one final? So I've had the good fortune of working really deeply in enterprise AI, rolling back 15 years. So there's Microsoft, Google, now here at NetApp. NetApp, as you guys know, you've proven intimately familiar with ONTAP and NetApp, right? Rock solid storage systems, best in class, industry leading data management capabilities. Everyone knows NVIDIA in terms of their compute and other software. That combination of storage plus data management plus optimized software and models plus optimized compute hardware is really powerful. What we've built together with NVIDIA doesn't exist anywhere else. It is really unique and singular. I'm very excited about it. And we really do think there's a huge leap forward for enterprises that are hitting all those problems we talked about before.
And to top it off, we have more than 100 exabytes of data. That's our opportunity, like 100 exabyte plus data sitting with our customers. It's our responsibility to make that data ready for AI.